Hello all, welcome back to Engineering Economy course. In our previous lecture we started talking about chapter 11, which discusses the uncertainty issues and how we deal with uncertainty. And we talked about what is a risk, what is an uncertainty, and how to deal with these. And we said that in this chapter we will learn the break-even analysis and the sensitivity analysis. We said that the break-even analysis is useful if the project depends on mostly a single factor. We can represent the equivalent worth of the project with respect to a single factor, such as the capacity utilization or the interest rate or the useful life. Okay, so in order to compare project alternatives with each other, or in order to decide if a single project is acceptable or not, we can use this break-even analysis. And simply in our procedure, what we do, we write the equivalent worth of the project and make it, for example, equal to 0 if it's a single project, or if we are comparing two project alternatives with each other, we make their equivalent words equal to each other, but the equivalent words are functions of this single factor. And we solve these equations for that factor, and we identify the point where we are indifferent. And then in order to make our decision, you can just estimate the value of that factor. For example, if it is the capacity utilization, you estimate the value. And if your estimation is less than the break-even point, you select one alternative, or if it is greater than the break-even point, you select the other alternative. And also you may end up, or you may get some insights whether this break-even point is very closer to your estimated value or not. If it is very close, if the break-even point and the estimated values are very close, it means that you need to be careful with your decision, because with a smaller change in your estimated value, your decision may be reversed. But if there is too much difference between these two values, then you can be sure about your decision. So in this lecture we will solve several other examples, and we will also do sensitivity analysis including multiple factors. So let's get started. We will first solve this example related to the break-even analysis. In this example, we assume that there are two electric motors, alternatives, and each of them are 100 horsepower, has 100 horsepower output. The first one is the alpha motor, and it can be purchased for this price, and it has an efficiency of 74%, and the estimated useful life is 10 years. The maintenance expenses for this one is $500 per year. The other motor is called the beta motor, and it can be purchased for $16,000. Efficiency is higher, 92%. Useful life is the same, 10 years, and the annual expenses, maintenance expenses, is $250. It says that annual taxes and insurance expenses for either motor will be 1.5% of the investment. So for the first motor, the investment is this much, multiplied by this value will give you the annual tax and insurance for that motor. It says that if the MAR is 15% per year, how many hours per year would the motors have to be operated at full load for the annual costs to be equal? So we want to find the break-even point with respect to the number of operating hours, so that the costs of these two motors are equal to each other. Also, we are given this information, the market values at the end of 10 years for both of them are negligible, and the electricity cost is $0.05 per kilowatt hours. So in order to solve this example, okay, we need to write the equivalent word of both motors. So you can use present word, annual word, or the future word. So let's use the annual word. In order to find the annual word of, let's say, motor A, okay, for A, what do? We need to convert everything into annual terms. And the first thing is the initial purchasing price. And we need to find the annual worth of this one. The MAR is given as 15% and useful life is 10 years. Okay, so this is the initial investment. And then we need to find the annual maintenance cost. And the annual maintenance cost for the first motor is $500. Okay, it's already annual, so you don't need to convert it. Then, with respect to the energy consumption, we have this energy consumption cost. Okay, so we need to find that energy consumption cost, and what will be the energy consumption cost? It will be the total operating hours. And you see the operating hours is what we don't know. So we can represent it by X, okay, number of operating hours. So assume that this motor will be operated for X hours. And we need to find the hourly energy consumption. So the motor has 100 horsepower. Okay, and we know that 1 horsepower is 0.746 kilowatt hours. Okay, so we need to convert this to kilowatts by multiplying 0.746, and then the efficiency of the motor, the first motor, is 0.74. Okay, so this is inside this parenthesis, this value is the per hour energy consumption multiplied by the total number of operating hours is the total energy consumption, and I need to multiply this by the energy price, okay, which is 0.05, so that this will be the total energy consumption. Okay, and then we also need to have this market value, but the market value is said to be negligible. Okay, so this is the annual word, and these are all costs. And this is for A. For B, simply we will do the same thing. By the way, we need to find this annual taxes and insurance. And these annual taxes and insurance, it will be another annual cost, which will be the initial cost multiplied by 0.015, okay, 1.5%. So this is the annual taxes and insurance cost. Okay, so this is the annual worth of the first alternative, and we will do the same thing for the second alternative. And as you can see, it's a function of this unknown operating hours, which is X, and we will make these equal to each other and solve for X. So this is for the alpha motor. Okay, for alpha motor, this is the initial investment. The annual value is this much. This is the operating expenses, which is a function of X. This is the annual maintenance, and this is the taxes and insurance for alpha motor. For the beta motor, we do the same thing. This is the initial investment and its annual value. This is the operating, the energy consumption, again, it's a function of X. Then we have the annual maintenance expenses and taxes and insurance. Again, the initial investment multiplied by 1.5%, and it's a per year basis. So what we'll do is we will make the annual equivalent of the alpha motor to be equal to the annual equivalent cost of the beta motor. So this is the total cost of alpha and this is the total cost of beta, and from here if you solve for x, we find that this x is the break-even point is $508 hours per year. Okay, so what does it mean? We need to compare now these two motors with each other. We know that if we operate the two motors exactly 508 hours per year, their annual cost will be identical. So we are indifferent. You can select any one of these motors at this point. But if your total number of operating hours is less than this value, or if it is greater than this value, you need to select one of them. But which one you are going to select? In order to see this, it is better to sketch the graphs of these two costs. Okay, so the alpha motor, for the alpha motor with respect to the hours of operation, so x, we said that it's a function of x, and in fact it's a linear function of x. So this is the annual equivalent value, and for alpha motor, if x is 0, the annual expense is around 3,000, and it has a slope of 5.0.4. Why it has a slope of 5.04? Because the function is 5.04 times x, okay, the annual equivalent for the alpha motor. So it is a line which starts at this point and has a slope of this much. The second one, the beta motor, the slope is this much, and it starts around here, and these two lines intersect at this point, which is 508, which is the break-even point. So the intersection point is the break-even point. And which motor should I select? If your annual operating hours is less than the break-even point, then alpha gives you less cost. Otherwise, beta gives you less cost. Okay, so now it is time to estimate your annual operating hours, whether you are in this region or in this region. If, as I told you, if you are closer to 508, it means that with a small change in your estimated value, your decision may be reversed. So you are closer to the decision reversal point. But if your estimates are far away from the break-even point, if you estimate your annual operating hours to be this much, then for sure you need to go for the decision with the beta motor. Another analysis that we can do in the presence of uncertainty is the so-called sensitivity analysis, and we will sketch the spider plots using this analysis. So this is an analysis tool that is applicable when the break-even analysis does not fit the project situation. So by using this sensitivity analysis, we make the impact of uncertainty, we make it explicit in our estimates for each of the factors of concern for our economic measure of merit. So the economic measure of merit is the present worth, annual worth, or future worth. Okay, and we make, let's assume that there's uncertainty on the study period, useful life, or the interest rate, and we estimate its value, and we try to find what several values of changes in our estimated value impacts or affects the present worth or annual worth, which means the economic measure of merit. So let's consider this example. Assume that we are analyzing a project using the present worth method, and we calculate the present worth using the estimated values, but assume that there are several factors The first factor, let's say, is the capital investment. We estimated its value, but the question is, what happens if this estimated value was wrong? And if there is a change in this capital investment of plus 40%, so it is 40% more than what we estimated. So what will, how will this present worth will be affected? Or it can be negative 40%, so it can be less, 40% less than what we estimated. So how will this change affect the present worth? Similarly, we can consider other factors such as the annual net cash flow. So we have an estimated value, and then we can look for what happens if it was 40% less or 40% more. The market value can be another factor. The useful life can be another factor for analyzing the effect of the changes. Okay, so we can consider this example to understand the concept better. So in this example, we are considering to enhance the vision system used in a postal service to sort the mail. So in order to sort this mail, we have a camera system, a vision system, and this system sorts the mail. But if it sorts wrong, then some mails can be misdirected. So in order to reduce this misdirection, we want to enhance this, and for this new system, the estimated cost is $1.1 million, and there will be an additional $200,000 per year of maintenance cost for this new system. But because of the reduction in the misdirected mail and etc., we have $500,000 of annual savings. Okay, the MAR is given as 10%. And the question is this: we can easily find the present worth of this alternative. And the present worth using 10% MAR is this initial investment plus annual savings minus maintenance cost. The useful life is given as 5 years. So we are using the present worth method. And as you can see, the present worth is greater than 0. So this project is acceptable according to this. But the thing is, there is uncertainty in these estimated values, and mostly the uncertainty is due to the investment cost, initial investment cost. We don't know for sure the value will be this much, and the annual savings. Okay, 500,000, this is an estimated value, and there is uncertainty on it. So we want to determine how sensitive our decision to these two factors. Of course, we will deal with them separately. So how we can do this? Actually, we want to find the point of decision reversal. Okay, currently we, by this value, since it is greater than 0, we accept. But let's consider the capital investment, this value. If we change this value, if we reduce it or increase it, at what value or with what percentage of change our decision will be reversed? So we will not accept, we will reject the project. So we want to find that point. And how we can find? Actually, considering this present worth equation for 10%, we write this. Okay, the current estimated value is this much. And we are assuming that there will be a change in this value, a percentage change. 20%, 10%, we don't know. We want to find that change. So with such a change, the value of this initial investment will be, we can say that the change will be X amount, X percentage change. Okay, so we can write this as 1 plus X times this value, and the annual savings minus the cost, 300,000, multiplied by P given A, 10% and 5. Okay, so this is the new present worth with an X% change in the capital investment. And if this value is equal to 0, exactly equal to 0, we are at the point of decision reversal. Okay, so we set this equal to 0 and solve for X. And when you do this, you find this X to be 3.4%. Okay, so what does it mean? It means that if this capital investment increases by 3.4%, then you will more than an increase of more than 3.4% will change your decision and you will reject the project. Okay, so by looking at this percentage and your estimated value, now you can make a decision. Okay, this 3.4% is a very small percent, and in real life we may end up with such a change, so I want to reject it. You can have this conclusion, or you can say that okay, 3.4% is a huge change. My estimated value is accurate, does not contain that much error, so I will go for this decision. Okay, you can conclude your decision in this way. So this is what happens in the case of capital investment. But we are also asked what happens with a change in annual savings. And as I told you, we will consider them separately. So for annual savings, actually we will do the same thing. We will write the present word, again the 10% more we are using. So this time we assume that the capital investment is this value. There is no change in this capital investment. But for this annual savings, look, annual savings was 500,000. So now we are applying a change on it. Let's say this time that there will be a Y% change, and the cost, the maintenance cost is still the same, and everything else is the same. And we want again this value to be equal to 0. We set this equal to 0 so that we find the point of decision reversal. And from here, we find this Y% change to be negative 2%. Okay, so this change can be positive or negative. Negative means that if annual savings is 2% less than this amount, okay, annual savings, if it is 2% less than that amount, then we change our decision. And as you can see, the change in the capital investment, when you compare the change in the capital investment and the change in the annual savings, we see that our result depends on the annual savings more. I mean, a less percentage change affects my decision. So it is more sensitive, my decision is more sensitive to the annual savings when I compare it with the capital investment. So the solution also given here. So this is the equation, present worth equation for an X% change in the present worth, and we find its value to be 3.4%. For the annual savings, we use this equation over here, and we obtain that a negative 2% change will affect the solution, the decision. And the thing is, after we obtain these values, now the decision maker, the responsible engineer, needs to think about these decisions, look at the original estimates, and decide whether or not a more detailed estimate is required or not. Okay, So depending on that decision, maybe they will do a more detailed estimation and change the decision or make the decision, or they will say that, okay, no need for a more detailed estimation and we can go for this decision. By the way, we assume that all other estimated values are held at their original amounts. Okay, there are no changes occurring in the other estimated values. We consider these separately, the capital investment and annual savings separately. They are not depending on each other. In order to analyze such factors, their effects, and the sensitivity of the decision to different factors, spider plots, the diagrams or graphs called spider plots, are very useful. So with an example, let's see what is a spider plot, how to sketch it, and how to interpret it. Let's consider the same example where we want to establish a new vision system. And let's consider now 4 factors. In the previous example, we only considered capital investment and annual savings. In this example, we also include the annual expenses and MAR. And let's consider the sensitivity of our decision to all of these factors. And in order to sketch the sensitivity, in order to analyze the sensitivity, we will consider a plus and minus 20% change in all of these values. Okay, so within the range of negative plus minus 20% changes in the estimated values, how will our decision be affected? The useful life is given as 5 years. To do this analysis, Excel will be very useful because we will sketch the graphs, and since we are analyzing 5 factors, and also with these let's say 4 factors, and for these 4 factors we need to analyze the effect of change between negative 20 and positive 20% changes. We will calculate the present worth again and again. So how we do it? Simply we do this. Consider capital investment. Its current value is this much. Okay. Then we find the present worth. Okay. So this 0% change assumes that we have this value, and in that case the present worth was this. We already calculated this value. Now what do? Keep every other thing constant in their estimated values. Change this one, increase its value by 5%. Okay, so a 5% change will change my present worth to this value. Okay, with a 5% change, it goes into negative. And then let's assume that increase its value by 10% and calculate the present worth again. Remember, every other thing is constant, but just increase the value of this one by 10%. Similarly, do this for 15% and 20%. So this is my range, okay? Plus 20%. So I did this by increasing the percentage changes by 5 units. But the thing is, if you want a more detailed one, you can do this 1%, 2%, 3% up to 20%. But actually, for this analysis, for this example, it is not necessary, because when we sketch the plots, you will see how the plots look like. And also, we need to do the same thing for decreasing the capital investment by 5%, 10%. So this negative means a reduction down to 20%. And for each case, we find the capital investment value. So this column simply shows me the effect of changes in the capital investment. And these are the present worths that we obtain by these changes. Now we do the same thing for the annual savings. The current estimated value is 5 $100,000, and with a 0% change, meaning that we are using this value, every other estimation is the same. Capital investment is this much, annual expense is this much, MAR is this much, and then we obtain the same present worth with this one. Look, so this row for each parameter, each factor is the same. And then keep everything else the same, but increase the annual savings by 5%. So what happens? 10%, 15, 20. Reduce its value by 5%, 10, 15, and 20. Do the same thing for annual expenses and MAR. And actually in Excel, in each of these cells, we write the formulas so that these formulas uses these values and these changes, percentage changes, and it calculates them automatically. So here actually instead of -20, if you write -30, all this value will be calculated, or this value will be calculated automatically by the formula. So the formula that we are using in these cells in Excel is this PV. So PV is an embedded formula in Excel, and it has these 5 arguments: rate, NPER, PMT, FV, and type. Okay, here rate, actually it is the interest rate. So when you are writing this formula, PV, so you are writing, for example, if it is the interest rate 10%, you are writing 0.0, if it is 10%, you are writing 0.1. Okay, this is the interest rate. The second one is NPER. NPER is the total number of periods. So in our study, for example, 5 years, we are using 5 years. Okay, so we write it 5. PMT is the annual payment amount. If, for example, we have such a cash flow, we are having these annual values, they are all equivalent. So for PMT, we are writing this A value. Okay, so in the previous example, remember 500,000 is the annual savings minus 200,000 is the maintenance cost. So if we subtract, this amount is 300,000. Okay, this is the annual amount. But the thing is, in Excel, there is a convention saying that if you want to find this present worth using this formula, you need to enter this PMT as a negative amount. So in Excel cells, so if you want to say that this is 300,000, you are writing is as negative 300,000. Otherwise, if you write it as positive, then the present worth will be found as negative. Okay, so PV formula finds or changes the sign. If you write positive for A, it finds its value as negative, otherwise vice versa. Okay, but sometimes we don't want to find the present worth of an annual equivalent, but we just want to find the present worth of a future value. Okay, this is present worth and there's future value. In that case, so we keep this empty, this PMT, this one, we keep it empty simply by adding another comma, and then we write the future worth to here. Let's say the future worth is $100,000, if this value. And again here, we also need to write its value as negative in order to get the present worth as positive. If, for example, we want to find the present worth of an annuity, not future worth, then we write here the value. Okay, this, of course, without comma, this 300,000, and then the future worth, if that does not exist, we leave it empty. It means that we put another comma. And the last one is type. Actually, it is optional. If you don't like, you don't write it. If you don't write it, it assumes that the value is 0. So this type is either 0 or 1. And 0 means that the payments are at the end of the period. But if you set its value to be 1, it assumes that the payments of the annuities, the future worth, and etc. are at the beginning of the period. Okay, so this is how we use this formula in Excel, and all the present words in the previous example are written using this formula. And after obtaining all those values in the Excel sheet, we can sketch the graph of this. And here, as you can see, we have 4 factors: capital investment, annual expenses, annual savings, and MAR. And these are the graphs in the range of a change -20%, +20%. We are sketching the present worth, okay? So this axis shows me the present worth. And remember, when the change was 0%, it means that we used the original estimated values. The present worth was around positive 33,000, okay? So this value here is 37,000 something. Okay, $236. So this is, as you can see, when the change is 0, all lines intersect at this point. And this is positive, which means that if the original estimated values are valid, then we accept this decision. Now let's have a look at the capital investment. So this one, as you can see, is the graph of the line of capital investment. And if we increase capital investment by 5%, as you can see, we end up with a negative present worth. And for 10%, 15%, 20% change, we can find their values. And again, for positive changes, we can, for negative changes in its value, we can find the present worth. Okay, for each one of them, for annual savings, we have this graph. For annual expenses. For annual savings, we have this graph, and for MAR, we have this graph. But the important thing here, there are some observations that we can make in this graph. The first thing is you need to concentrate on the slope. Okay, the slope of the lines shows the sensitivity of the decisions to each of these factors. As you can see, this one has the largest slope. What is this? It is the annual savings. Okay, so it means that your decision is highly sensitive to this annual savings. A small change in the annual savings ends up with a large change in the present worth. But on the other hand, look at this value, which is the MAR, and as you can see, it's almost closer to a horizontal line. The slope is too small, and the thing is, it says that your result is not too sensitive to the MAR. Okay, the slope is very important at this point. And also, from this graph, you can observe that the original estimated values are larger than 0. It means that it's acceptable, but still it is it's closer to 0. And with, for example, less than with 2% change, okay, this is 2%. 2% reduction in annual savings, you end up with negative present worth. Or 5% change in this annual expenses, 5% increase ends up with again 0 present worth, and etc. So you see these points where these lines intersect with 0. This point here, this is the decision reversal point for annual expenses. This is the decision reversal point for the capital investment. This is the decision reversal for annual expenses, and this is the decision reversal point for the MAR. As you can see, the decision reversal point for MAR is almost 15%. So we say that our decision, we are quite sure with respect to MAR. But when you look at this annual savings or to this capital investment, we see that it's quite closer to this zero, so the decision reversal point. So if we summarize the spider plots, what we can obtain from these spider plots shows the sensitivity of the present world. So since we used present world in this analysis, actually you could have used this annual word or future word also. So we can say sensitivity of the equivalent word to percent deviation changes in each factor's best estimate. Okay, so this is what spider plots show. Other factors are assumed to remain at their best estimate values. So when we want to analyze, for example, capital investment, we increase its value by 5%, 10%, and etc. And when we do it, we assume that all other factors remain at their best estimated values. Of course, this may not be the case in real life. The most important thing, one of the most important things that you need to concentrate on these spider plots is the slope of the curves. Okay, if the slope of the curve is steeper, then it means that the result, the present world, is more sensitive to the factor. If it is less, the slope is smaller, then it is less sensitive. And another important thing is the intersection of the lines, of the factors with the x-axis, because these intersections shows the points of decision reversal when the present world becomes zero. Okay, and whether these intersections are closer to the original estimates or far away from those original estimates. So if we summarize for this example what we learned, again, the degree of sensitivity is obtained by the slope of the curves and also the intersection of each curve with the zero, the abscissa, shows the decision reversal point. And with this example, for this example, we understand that the present world is insensitive because the slope is too small, insensitive to the MAR, but it's quite very sensitive to the changes in capital investment, annual savings, and annual expenses. Okay, by looking at this, you can understand that, okay, we don't need to further analyze our estimates for MAR, but we may have another detailed look on our estimated values for capital investment, annual savings, and annual expenses. Let's solve another example to understand the concept of spider plot better. So assume that you have two options, either to buy a house with $150,000 or to rent it. If you use the rental option, the conditions are this. So the rent is $1,200 per month for the first year, and the monthly rental fee will increase by $25 for each subsequent year of renting. So we will live in this house for 5 years. Also, we need to pay $1,200 as deposit payable, and when at the end of the 5 years, it will be refunded. And the renter's insurance is $35 per month. But if we purchase this house, we need to make a $30,000 down payment at this time, at time zero. And then we will finance the remaining amount with a 30-year mortgage. And this 30-year mortgage will have 7%. So what does it mean? It means this. So we pay this 30,000 at time zero, okay, to the homeowner, and then the remaining $120,000 we get it from the bank, but we will pay that amount to the bank in 30 years. Okay, and in order to pay that amount in 30 years, we will pay with an interest rate of 7%. Also, at the end of 30 years, in order to close this loan, we need to pay $2,000. Okay, and we are paying this at the time of purchase. So at this time, we are paying this $2,000 to the bank. It says that property taxes and homeowners insurance total $200 per month, and the maintenance is expected to average $50 per month. The resale value of home after 5 years, because you see we get the loan at for 30 years, but this we are considering to live in this house for 5 years, only 5 years, and it means that we will sell that house after 5 years, and the market value in 5 years will be this much. The commission paid to the realtor at the time of the sale is expected to be 7% of the selling price. So again, there's another price that we pay here, which is 150,000 multiplied by 0.07, which is the commission paid. Okay, so now we want to compare these two alternatives, but of course there are different factors. The personal interest rate is 10% per year, which is compounded monthly. This is MAR, okay? And this 7% is the interest rate for your loan, okay? So the question is it more economical to rent or purchase this house? We can answer that question by simply finding the present, future, annual worth, or internal, external rate of returns, and etc. But it's said that examine the sensitivity of the decision to changes in resale value of the home, the mortgage rate, and the length of the ownership. Okay, the resale value, which is this one, the mortgage rate, which is 7%, and the length of the ownership, the 5 years, instead of 5 years if it is less or more. We want to analyze the sensitivity. Again, in order this analysis, it is easier to use spreadsheet, Excel, and we will establish an Excel sheet that will find the present worth of both alternatives, purchasing and renting, but that will consider all three factors, and by considering different the changes in these factors, it will obtain the present worth. And here actually you can see the formulas that you need to use, you can use in this Excel sheet. And the Excel sheet itself is given here. So if you like, you can by yourself, by inputting the formulas into the corresponding cells in the previous, given in the previous slide, you can obtain the same value. Simply what we do here, we compare the renting option and the purchasing option. So we write the original values, the original estimated values here, okay? And then we find the present worths here. So the deposit value is this much, and we pay this deposit at current time, but we will receive it after 5 months. So its present worth, it will be something like this. So we are paying this deposit now, and we are obtaining it 5 years later. So the present worth of this cash flow is this much. Similarly, the monthly payments of rent and the change of this rent, it increases by 25%. Here in these cells, you have all the formulas given in the previous slide. And the thing is, by using these original estimated values, we calculate the present worth of these alternatives. For the first one, for the renting alternative, we obtain the final result to be this much, and for purchasing alternative, it is this much. And when we compare these two with each other, we see that purchasing has less cost in terms of total cost, and the difference in between them is this much. So our decision is to purchase the house. Okay, so this is the current decision. Now, the thing is, this is the original solution, our decision with respect to the current estimated values. Now, when we consider the changes in the given factors, the selling price, mortgage rate, and the length of ownership, we see that we can find the break-even values of these factors. The break-even points, remember, the values that will make the present worth equal to 0, so that the change of decision reversal. And also we can find that the break-even value for this future selling price corresponds to a negative 1.25% change in the current value. Again, mortgage rate, if it is increased by 2.86%, then it changes. And also, this negative 21% change, okay, it is the length of the ownership. If it is changed, reduced by negative 21%, then we change our decision, we reverse our decision. So these values show the sensitivity of the results to these values. And using the same idea in the previous example, if we sketch the plots for these three factors, the present worth and the changes, so now here we used a range negative 30, positive 30, and we increase the values by 10% at each step in this case, okay? Since they are lines, actually, increasing and decreasing them by 5% or 10% or 1% at each step will give you the same line, because the slopes are identical. The slopes of the lines are identical. And then with 0% change, you can see this is the current decision. For renting, renting is better. So this is actually the difference between renting and purchasing. Purchasing was more advantageous. Then with a 10% change in future selling price, we see how the present worth changes. And as you can see, this graph is the future selling price. And as you can see, the slope is higher. It means that, it's the steepest slope. It means that your decision is depends on future selling price, highly sensitive on future selling price. But if you look at the length of the ownership, it's insensitive to the length of the ownership, and there is moderate sensitivity to the mortgage rate. And also, if you look at the intersection of these with 0 present worth, as you can see, they are very close to 0. Okay, the intersection points, the decision reversal points are very close to 0. It means that better estimates are absolutely necessary for this example to understand, to come up with a best decision. Okay, so this is the end of this chapter and this topic. Please review the material and solve examples by yourself to understand it better.